So hello everybody. It's been a while since my last post. What we're going to do today, it's quite interesting. It's one of the most famous, let's say, 3D tools or techniques or applications for 3D model reconstruction that appeared again in a couple of past years. Today, or currently, those techniques are more powerful, faster, more accessible. Now that we are passing or beyond that GPU crisis that affected the world because of COVID and so on and so forth, we have the option to get reasonable or reasonably priced GPUs, so we can run these models locally. We can apply machine learning models in a faster, easier way. So today we're going to see what we have here. We're going to go through like nerfstudio. That nerfstudio is actually quite easy to use. I'm going to show it to you because you can do quite interesting things. So you can train models to generate these neural radiant fields. It's like some sort of like photogrammetry, but you're not producing meshes. You're producing, let's say, like pixels. So you can create videos, and also you can create meshes. Today we're not going to cover that. We will cover installation and basic functioning, and then we will train our own model. And I will teach you because that is very interesting. Still, most of these techniques rely on something that is called COLMAP, but I will show you an alternative way of creating your own models. Because COLMAP has still some issues installing on Windows. If you have a Linux machine, you can just go and do it, but in Windows it's still like kind of tricky. And also COLMAP, that is, I will explain what it is. It's not a very good tool in my opinion. So the first thing that you need, of course, is to go to anaconda.com, because we want to deal with, or we will have to deal with the creation of environments. So if you go to anaconda.com, you can download Anaconda, and it's a really easy setup. The way that you install it, I'm just going to download it. I'm not going to install it, but I will show you. Just download the installer. This will apply for Windows. Sadly, it will not work on Mac because we need CUDA cores. We need CUDA toolkit and tiny CUDA. So when you download this 64-bit setup, you just agree, next. You basically say yes and next to everything. So you will have Anaconda. How do you check if you have Anaconda? You go to your menu and you write Anaconda, and you can see. Actually, let me move. If you go to your menu, Anaconda, and you will see two things that are necessary for this, that are installed. You will see the Anaconda Navigator. That is what we have here, but we will use mostly the Anaconda prompt. So let's use that. Install the tools, and we are ready to start. So let me move this back here. So I will put the commands below in the description. So we will start with the installation of NERF. The first thing, we need to create an environment. So to create an environment, we need to do a couple of things. Again, you just go to your start menu, Anaconda prompt. You will see a command window. I'll make it bigger so you can see it, and you can say like conda create -n nerfstudio, and we can say -y, and we can specify the Python version. We can do 3.9, but I think 3.8 will do the job. That's the way the description of their tutorials is like indicated. So with this command we can create the environment to have an isolated installation of all the dependencies. So we just do that. If you're not familiar with Anaconda, basically what it does is among like other things, it allows you to create specific environments. So again, you can isolate the installation of different things. So you see that now is creating something. With the -y, we're just saying yes, just create everything. Install what we need to install to create again. I'm going to clear the screen. So if I say now conda activate nerfstudio, you see that now we are in nerfstudio environment. So now we can start installing a couple of things. The first thing that we need is upgrade PIP. So we can say python -m pip install upgrade PIP or pip, and now we need to start installing the things that we need. So the first command, again I'm going to write it here in the description, is this PIP install. We are installing PyTorch with Torch Vision with CUDA 11.3. So this is basically like one of the main requirements. It takes a little bit. Usually like Anaconda, it's slow for the installation. In this case we're using PIP, so that is good. My computer is a little bit slow for some reason. But now you see that it's installing everything. It's installing all the packages, NumPy, Pillow, basically everything, so everything runs smoothly. So you wait for a couple of minutes. You see that all the dependencies are installed. And this is something that it's very important. I will recommend that you, in some, you go, for example, to your desktop, you create a new folder. We can call it NS for nerfstudio, because after a while, not in this step, but in the next one, in 2 steps, we will install nerfstudio. So you wanna have it in a directory and basically everything organized. Now we need to install TinyCuda. This might give you an error. That error will be solved. I mean, if you get an error that there is no a C++ runtime install in your computer, go and install Visual Studio, not Visual Studio Code, Visual Studio 2022. And it will solve all your installation problems. So if you do this, PIP install, this is the installing directly from the source. Again, you will wait a couple of minutes and you will have TinyCuda installed in your computer. But if you get an error, again, after this step, you probably will see an error if you don't have Visual Studio 2022 installed, or a nice installation of Studio 2020, for example. So do that before you follow these steps. So after you install TinyCuda, that takes around like 10 minutes probably. I think we're good to go. So the installation of nerfstudio is super easy. To just go like PIP install nerfstudio, and it doesn't take much time. So you will see start installing a couple of things. We need to know a couple of so you will download all the libraries and files that are necessary. You can see here it installs a lot of things, and then we need to generate data, but I will show you one specific thing. We're going to train one specific data set, and I will show you at the end, the final part of this video, how to create your own data set with an alternative method. And in the next video that will come probably next week, I will show you another technique if you have an iPhone with LiDAR capacity. It's even like easier to generate NERF data. So after you do this, we're pretty much done. So you see that installs like a lot of things. It doesn't take as much, or it doesn't take as long as TinyCuda, but we're good to go and do something. So for example, we can do NS, basically like all the functionality of nerfstudio is like NS something. So in this case, we can do download data, and we can download, for example, a dataset. We can use, for example, like Blender, or we can use nerfstudio. Let's start with Blender. So if we do this, we will start downloading from a Google repository, like 1 point something gigabytes of information. So if I go now, for example, to the folder, you can see that in NS we have the data directory, and we have here a repository with things that are needed for training or testing, for example, nerfstudio to do a neural radiance. We have a transform file. This is a JSON file that we can, for example, like open with Visual Studio Code, and what it does basically, it has the information of a set of cameras associated with also an image. So basically it gets like a position of a camera, the transformation matrix, the rotation, the camera angle, all the information from different images. One thing that we should know is that all the images should be the exact same size, otherwise it won't work. So if we go, for example, to here like NERF synthetic, ficus, train, these are just like a bunch of synthetic data, information about cameras gotten from like a 3D model. But we're going to test it with first, one of these things. I'm going to cancel this and I will show you how to generate your own dataset. So I'm going to close this, I'm going to minimize this. Let's start and train our first model. So we can do the following thing. So you can start again with this data, like the data set that you download from Blender and so on and so forth, or you can just like start training your own model. So you can do, for example, NS train, and you can do a vanilla NERF, NERF. We can do, for example, this viewer, was it? Yeah, viewer, and we can say like viewer that WebSocket dash port. We can say 7008, for example. Let's see if this works. I think this should start training without a problem. Vanilla NERF error argument. Oh, apparently we cannot see this. What did I do wrong? Oh. This should work. No such file as data Blender Lego. This is giving me like a weird error, so let me check if this works without any yeah, it's so weird that if I specify like a viewer, it gives me a problem. So for example, here we can train I mean, this is good to test if everything is working, the installation is working. We can choose don't visualize. If you want to see, for example, how the training is going, you can create a weight and bias account, or use an existing weight and biases account, or don't visualize anything. In this case, I don't want to visualize anything. Hopefully it will, and it gave me an error. It's giving me too many errors. It says that it cannot find data blender Lego. Let me see if I do this here. That will be kind of ridiculous. So let's see. No. So what we need to do actually is giving me like some errors, like stupid errors. So I'm gonna do one thing again. You see, this is the level. Users, my account Diego. I will download the Blender dataset here, because for some reason it's giving me errors with my desktop. Probably it's because of OneDrive or something like that. Yeah, that's kind of it, annoying. So Diego, and we can see here that it's downloading. Yeah, everything. This should be fine. So let's see if everything works. I'm interested in seeing that the training process works. So see, NERF synthetic. Oh, it's expanding. Oops, it's oh here. Blender chair tests. Okay, let's see if this works now. So let's try to reutilize one of the previous commands. Let's try to run the vanilla NERF, the original implementation, and with the viewer to see if everything works. So we execute this command. Yeah, now it's loading, like catching the images, loading the batch. So one thing that is very interesting is like super cool that now it's working, loading everything. It says that we don't have any previous training, but here it gives you an address that if we go, if you use Brave browser, it won't work. So I recommend that you use Chrome. You go to that address, and you will start seeing this. This is nerfstudio, an application. I think it was developed in React. That you see, just like photogrammetry, it starts loading all the images, just like photogrammetry, like with the position, the orientation, the rotation, and magically it will start showing you the neural radiance field. So basically it's like this smoke thing that you can then post-process and turn into a nice 3D model, for example. So this is interactive. So now you see, like it's trying to, something is showing up, but we're training just the vanilla example, one that you can find in like papers about radiant fields. So yeah, we're not interested on this. So we know that it's working. The server for this is working. So let's just stop this. Let's stop the training. And let's try what the people from nerfstudio claim that it is their best algorithm. So let's just do, for example, I have some commands here. We can train with instant NGP or nerfacto. That is the other one. So let me see if this works. I'm gonna try, you see, like NStrain. Yeah, it's giving me one error. Let's see again how we can solve this. Path errors. If we go to the data folder, Blender. Okay, that's the problem. So here we need to actually this is data Blender. Let's try to do the ship. Same arguments, viewer, yeah, for some reason this one it doesn't. Probably we cannot train Blender. Yeah, it cannot find that because the data are like transform tests. Let's do one more time. If not, we will move to our custom because that's the important. I'm just trying to show you ways on how this could work with the data that they provide. If not, that's fine. Yeah, it's giving me the same thing because the format is different. Okay, whatever. We don't care about this. I just want to train our factor, so just give me 1 second. We're gonna do a we'll download the nerfstudio dataset to see if with this we can actually train our model. So we downloaded that. We will say like ns train nerfacto as our algorithm for training. We will specify that we want to visualize the results in the viewer. The data will be in data nerfstudio. Poster is the one. So if we go to the folder here, data nerfstudio poster, and this is interesting because here we have the transforms JSON. We have some directories with images. Basically, it's just a chair. So let's see if this worked, because this algorithm is faster and more accurate. So poster trainer, viewer, that WebSocket socket 7008 socket port, sorry, WebSocket port, not socket port. It takes a little bit. Again, one error. What is my error here? Viewer this. I didn't say, like, so it will tell you like, yeah, the options here, so I didn't put one thing. I have another error. ns train nerfacto minus data. Viewer with socket port. What is wrong here? Oh, sorry, this was the other way around. This viewer. Now we're good. Sorry about that. Yeah, you see that now it's working. It's loading the data. No checkpoints to load, so it's training from scratch. Let's copy this. Go to Chrome. We have nerfstudio. You see that it loads the images, and after a couple of passes it should start showing the training process. Yeah, there we go. So you see, for now everything looks like kind of cloudy. You can pan, you can orient, and this is super cool. So actually we can hide the images, and you see that how through every step, like, we're 1% of the training process and we already see this. So it's like calculating, let's say, like let's think about it as a pixel in space. It's not even a point, right? But then you can convert into that. You can add more resolution. It will take longer to train. If you're familiarized with the NERF or neural radiance fields, you see that because these are pictures, let's click here. this is pointing this is pointing that. So it doesn't have information of what's beyond, right? It doesn't have information outside the pictures. So this is why everything looks like kind of cloudy, but it looks pretty good. So you will see this kind of things once you pause the training. So let's say we want to pause the training. Let's see if we can do something. Hide the images. I think we can add, yeah, we can add a camera. So you see, you say like, oh, this is a good perspective. Let's add another camera here. Let's add another camera that maybe does this. Then a camera that goes here. Then another camera that does this. And then we can close this and we can play. You see the animation of the camera rendering. If you go to render view, and this is the nice part of it, so you can play it again, so you can see that it creates an animation. So now the cool part about this is that you can after this process, if you go to render, where is it? Yeah, render, to render a full resolution video, then you can just, because it already saved a checkpoint, for example. Now the results are not very good, but you can just copy this command and paste it. Let's try it actually. Let's just stop this, Control and C, and if we, oops, did I copy the command? Copy command. Yeah, there it is. I just pasted it. I think it saved a checkpoint, so it should create a video. It's loading the data. Oh, I don't have this, so I need to install it, and that's a little bit painful. If is necessary only if using videos as input, so this shouldn't be a problem. Yeah, why is this giving me that? To render full resolution video, the video, blah 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 blah. There is another way, because now we have the server disconnected. That's the path. So that's also a cool thing. We can create a new path or extract it, and we will have the possibility of reusing that for another model, for example, if we like what we did there. So you see that now we don't have the server running. We have the path, but we don't have more information. You can change here like different options, resolution, more resolution. It will cause like slower training. Again, the cool thing is that everything works and is visualized on web. So eventually you can use, for example, like in Ubuntu virtual machine to process everything. If you find errors, so probably I will cover that in the next session. You can change, yeah, you see like options, close the spline or not, add cameras, and so on and so forth. Load path or export the path. For some reason, yeah, it's weird, because it should I don't want to install ffmpeg. So if it doesn't work now, it's okay. I didn't want to do this for this video. It will come from a next. Yeah, it's a pain in the butt. So I'm gonna show you how you can create your own data set. Right, that's the meat of this video, beyond like installation and stuff. We're already like 30 minutes. So what you can do, if you are familiarized with photogrammetry, there is one specific project or program, sorry, app that is called Metashape. This is for doing like all kinds of photogrammetry. So one of the cool things about this is that it's really easy to use. This is the one that I've used many times. So what you can do, where I have my images here. So let me find, yeah, I have a bunch of images here that we can use to train a model. You don't need too many images, so in this case these are drone images. Let's just use, just for the sake of this bunch of images here. You can just drag them to here where it says chunk. You have a free version. If you go to Agisoft, you can download the free version. You don't need the full paid version. It's an evaluation, so that will be fine. I'm using Metashape again for this. You have the cameras, and you see that you have a list of cameras, and these cameras are not aligned. It means that you don't have anything processed. So using this program, you can go to workflow, align photos. You can use like the highest or high resolution, and it should take a couple of minutes to do the job, and I will show you the output once it's finished. No loading. I mean, just it's going really fast, like charging everything, detecting the points, because I'm using a very powerful computer with a 3090. You see here with a 16-core GPU, 128 gigs of RAM. So probably if you're using, let's say, a laptop, remember that you need a capable NVIDIA card that supports CUDA. So yeah, actually it did the job very fast, and it's perfect alignment. So it creates a sparse point cloud, actually pretty good one. So you can understand here the structure of the roof. This is an old building that I don't know why I have this footage. But what we want to do now is to let's create this data set. First, I'm going to copy these images. I should have done that before. Let's go to where I have the data set. So users, Diego, data. Let's create our own folder. Custom all B from all building. We will create one folder that will be called images. We will paste our images here. You don't need this amount of images. We have 84 with 30-ish. You're fine. But that's cool, just to show that you can do it with more. So once you have the images here, you want to go to File, Export, Export Cameras, and then you want to go to the folder where you have your data. There is here, custom, and here save it as like, I don't know, like all B. And it will save an XML file that will contain all the information about the cameras and the image, like basically like the position of the camera related to that image. So all B, save. So it's here. And now we need to do one more. So one person called Enrico Ahlers, he has this AGI to NERF. It's a repo that converts Metashape camera location to NERF conversion. So you can use it with install NGP, but actually it works with NERF factor that is faster and more accurate. So we will do that. So we need to do a couple of things. Let's copy the address here. Let's go to our command line. cd data, cd custom old b, and we will do git clone. We will clone his repo. And the only thing that you need to do actually is, let's see the documentation of his implementation. Oh, it's super easy. So let me just put it on the side. You just need to do Python agi to nerf.py, the XML, it's called old b.xml. So how do I know that? old b.xml. So we just need to input that and let's execute it. Probably it's not going to work the first time, and we need to install some dependencies. I'm not sure about that. It cannot. Oh, sorry. Yes, I installed it here. So actually, let's move. The only thing that we need is just this the script. So let's put it here. Now we can execute it because we are in the same level of the right directory. So, oh, actually, it's working off the shelf. So, yeah, it did it. So you just need to compute the center of attention and transform. So let's see the differences here. So this is the XML file. So it's a lot of garbage. It's like it has like this XML type of structure, and this is a script that is very simple but very powerful. It converts all the camera extrinsics and the rotation and images. You see that it's the file path, the sharpness of the image, the transformation matrix, so it can be correctly interpreted by nerfacto. So now it's very simple to train our model. One thing, probably if you run this, probably I had it installed. If you run this this script, probably you need to install OpenCV. So for that, it's really simple. You just do like pip install OpenCV-Python, and you're golden. You do that, and probably that's the only dependency that you need to install. So let's go back a couple of directories and let's do ns train nerfacto. What else do we need? Sorry, I forgot about the command to try train this. Oh, this, sorry, there's dash this viewer data, and this is in data custom old b. That's it. And then viewer that WebSocket dash port 707. So if everything is correct, this should work and start training. Okay, no data custom old b. Oh, of course. Let's put the reference. Well, now it should work, I hope. Oh, no, okay. You need to go one level down. Sorry, I was not in. Yeah, now it's loading. Sorry, it was again a typo. It's loading everything. We can go to this URL here, and it's loading the images. Pretty good. It used to be like a lot of work to actually do this with NERF, like a couple of months ago, just like generate this. But now to just do like Metashape, like you're doing like any type of photogrammetry, You see it calculates more or less like the bounding box for start processing the thing. It's telling me now that there are no checkpoints to load, and boom, it just starts training. And you see that little by little it starts generating our neural radiance field of the building. You can get close to it. This is actually pretty nice, I'm not gonna lie. And it's faster than photogrammetry. Of course, we're not processing a mesh. You can increase the resolution as well. So you can go like really high, and it will take more information. One thing that I want to show you for sure, if you go to Task Manager, you see the building showing up. If you go to Task Manager, and if you want to check the performance of the computer, you see it's using a lot of CPU. If you visualize to the logical processor, it's using pretty much like everything. I'm using a 5950X processor, but if you go here, it's a like the NVIDIA 3090. It's using 7 gigs out of 24. It's not too demanding, to be honest. And in terms of RAM, I'm using RAM is using a lot. It's using I mean, including like system files and all the stuff. The system usage is like 40 gigs out of 128. If we check the process, it gets a little bit slow. I don't know why. It's like I'm using Windows 10. I can't stand. For some reason, it's not showing this. Can you show me? Okay. This is Screencast. This is Google Chrome. CPU. What is using CPU? Yeah, Python. You see it's using like 49%. The whole process is using just like 10 gigabytes. It's not too much. So this is very doable with a laptop. This is very nice. You see we're 10% of the training process and we are already getting really cool results. This is something in Santiago, Chile. A building, a really old building. So again, the viewer is nice. If you click on one image, double click, you see what you are seeing. So this is it for this video. For a little bit more than 40 minutes. You can just try with your own stuff. You have all the tools. So that's it, and wait for the next video when we're gonna do a couple of more interesting things, like try to extract a mesh, for example, from this. But I wanted to show you this very nice tool, NERFstudio. Powerful, very cool. See you next time.